Well, welcome back. Today we're going to be talking about solar ovens and heat transfer. This is not only going to talk about thermal energy and how we could use it to cook things and that, but it's going to lead perfectly right into our project, which is on making a solar oven. You've probably already thought about or know what a solar oven is, but if you don't, we're basically taking the sunlight and we're going to convert that into heat or thermal energy. To do that, once we have that heat, we want to capture it for cooking, right? So kind of like an oven. And some people use it around the world because they don't have other fuels available like natural gas or electric. So this is something we're going to do. We're going to be taking some knowledge that we learned in class and apply it to building our own solar oven. The main idea here of our project coming up will be, can we get enough heat to melt a marshmallow and chocolate to make a good, delicious s'more? But before we can build the solar oven, we got to actually ask ourselves, how are we going to capture that heat? How are we going to get that heat from the sun, hold it enough so that we can make our delicious s'more? Well, let's talk about some of those things now. We want to definitely have what's considered heat transmission, which means that we want to create this thermal energy and then transfer it from the sun's energy to the s'more in order to melt it. And there's many different ways to do that. In this picture you see actually it mentions something called convection, conduction, and radiation. We're going to talk about all those things plus another here in just a few moments. Conduction is the first one. If you've ever left a little spoon in a hot coffee mug or that, you know that the spoon eventually gets hot if it's metal. The reason for that is there's a transfer of energy. The heat from the coffee transfers to the spoon, which means that basically the energy from the coffee starts making the molecules in the spoon vibrate more, collide more, and create a higher kinetic energy level, which means that the temperature of it rises. So for conduction to happen, you actually have to have the objects touching. But we cook a lot of different foods through conduction. If you ever put anything on the stove, turn the flame on, etc., the hot fire is touching the object, so the heat from that reaction of the gas burning is transferring then to the frying pan, which then transfers to the food to cook it. This relates a lot to the kinetic theory as well, because the heat causes the molecules to move faster, which then makes it hotter. So once again, as energy goes up, that's the same thing as the temperature going up. Convection's a little different now. Convection doesn't necessarily mean that they're touching, but the heat is transferred through some type of fluid. Notice I didn't say liquid. A fluid is just something that can flow. So something like air or water could fall under what we call a fluid because it can flow. When something is heated, we know that it gains energy, and because of that, it'll most likely expand, have higher kinetic energy, and therefore change its density and move. In this pot of boiling water, down here is a lot more energy because of the hot flame. Once the water absorbs that energy, it's going to become less dense because it's going to have higher kinetic energy, and the molecules will spread out a little bit, making it less dense. When it's less dense, it's going to rise to the top. When it cools off again, it'll become more dense and come back down. So you can see how this change in energy can actually make the water molecules move. That is the phenomenon of convection. Radiation, though sometimes confused, we're talking about heat radiation, not radioactivity. But the idea is there is energy from inside that is being given off in some type of energy form as energy waves, that is. So you're not really touching the object, but you're still feeling the energy transferred to you. If you take a look at this picture on the side of a fire, you are actually getting the radiation, the heat radiation that is, from the fire, and it's heating you up, giving your hands higher energy. Sometimes we heat food and warming plates in restaurants by infrared radiation, which is just an energy level that'll keep food hot. But it's through this radiation that actually keeps other objects at a higher energy level. Now we have a lot of different things going on for our solar ovens with the sunlight hitting it. So you have to think of two ideas, heat reflection and heat absorption. If heat is being reflected, it means it's hitting on an object and bouncing back off. Can that be helpful for your solar oven? Not sure, something to think about. But it definitely is important to consider that if you think that can help you cook your food. The last thing then is heat absorption. If you've ever worn a black shirt, you know that the sun and the energy from the sun is absorbed into that cloth, and because of that, it ends up warming up. And obviously, the longer it is exposed to the sun, the hotter it gets. And again, since you're absorbing energy, if the energy increases, we know then that the temperature increases as well. So think about reflection and absorption as well when you're going to be building your solar ovens. So the main question is, how will you or you and your partner build your solar oven? The idea here is to go online, start researching what some people have done for homemade solar ovens. When you have an idea of what it takes to build up enough heat to melt that marshmallow and chocolate, start thinking about how big do you want your solar oven? What types of supplies do you need that are around your house in order to build that? And think about heat transmission. Do you want to use conduction, convection, or both? Do you need to reflect the sunlight? Do you need to absorb the sun's energy in order to cook that s'more? But I don't want you to spend lots of money here. I want you to think about supplies around the house that you can use. Think of shoe boxes, pizza boxes, saran wrap, foil, etc. But create your best idea of a solar oven, and we're going to test that out in a couple days. But the information that we just talked about can definitely help you make better choices in building your solar oven. So best of luck. Start brainstorming, start researching online. Plenty of things to look at through YouTube and Google. And best luck. May the best solar oven make the best s'more. Enjoy, and I hope your s'more becomes tasty and delicious, all while being educational.